So I wanted to give some context on what you're about to be watching. I was on a call with one of my Patreon supporters. It's for one of the reward tiers where I do a coding session where I answer any questions and kind of go over code and whatnot. So in this video, it is a screen share where I'm sharing my screen and I'm on a call with one of my supporters. And in this session, we go over how to handle multiple APIs in GraphQL and how you would go about normalizing that data, and then how you might go about actually caching the data so you're not fetching from the APIs every single time. So you're going to be watching a recording of that. And so without further ado, I'm going to just run that right now. So, all right, so I guess if you want to just start off with what you kind of want to go over, and I kind of prepared a little something that goes over kind of like how GraphQL you can fetch different from multiple different APIs. But if you want to kind of just talk through what you're trying to do.
Well, I think it's exactly that. So it's really how do you kind of hit two different APIs. So an example might be where you're building a recipe app and you want to pull recipes from two different APIs. But again, those APIs are going to have different name properties. So how do you kind of resolve those different types of things together? So they might handle dates differently, or they might call things differently. So how do you kind of hit these two APIs and kind of merge them together, and then potentially then kind of integrate that with a calls to Prisma as well?
Yeah.
Does that make sense?
Yeah, that definitely makes sense. And the nice thing about GraphQL is it's actually relatively easy to do that sort of thing, slash it lets you be fine grained about where your data is getting from different fields. So it's very easy to say these fields I want to get from this API and these fields I want to get from another API. And are you a JavaScript or a TypeScript guy?
JavaScript.
Okay, cool. I didn't know, so I went ahead and
Yep.
just wrote this little example in JavaScript to be safe.
Great.
And this is basically just the Apollo server example that they have in their getting started, and I just added a simple field onto it to show you like this is the most basic level of fetching data from two different APIs. So what I have right here is here's my schema. So all it does is it has a single query called advice, and advice is a type. And in my advice type, I have two. I either get advice from Kanye or I get advice from Chuck Norris. And those are just strings, but they could be their own data types if you want to too. And then if we look at the
Makes sense.
resolvers for this, so you'll notice like in my advice one, I'm actually not even resolving any fields. I'm just returning an object that's empty. And then what I do is I actually resolve the individual Kanye and the individual Chuck Norris fields. So inside of the advice object type, I guess,
Hmm.
we have Kanye and we have Chuck Norris. So these are just resolver functions. So in this case, I didn't really need any parameters from the resolver functions. And they're asynchronous. So that allows you to fetch from the API. And so here I'm just saying fetch, and here I'm hitting the Kanye API. I'm getting the response, getting the JSON response from it, and then I'm just saying data.quote. And then say Chuck Norris, I'm doing the exact same thing, fetching from the Chuck Norris API, grabbing the JSON for it, and I'm returning the value of it. So if we like take a look at what it looks like to actually run this guy, it looks something like this. So we have curly braces advice I'm getting from Kanye and I'm getting from Chuck Norris. And if I run that, I'm going to get a quote from each one of them. And again, the fields are resolved individually. So if I only wanted a Kanye quote, we are only hitting the Kanye API with that. And if I only want a Chuck Norris quote, get rid of that. We can do that. And then we're only going to hit the Chuck Norris API. Or we can do both and we'll hit both APIs. So does the basics of that make sense?
The basics of that does make sense.
Cool. So that's basically where you're going to go, is you're just going to expand off this concept. So you're going to take the individual fields that you want to resolve. And obviously right now this is basic because I just have strings, but they could be their own types. So for example, if I was fetching from Prisma, I might have a whole Prisma type for a recipe, for example. And maybe I'm returning the recipe from Prisma, and then I just return it from here. So you create a schema type for it, and then you resolve the fields like that.
And so for obviously in theory, the Chuck Norris API and the Kanye API, those might have, 20, 30 properties each. And would you then, if you want to do that, would you then create one function for each one of those that you want to hit?
So we can take a look, and we can
Yeah.
we can take as many fields from the API as we want, or as little fields as we want from the API.
Right.
So for the Kanye one, it's only giving me a quote and ID. Let's see what we get from the Chuck Norris one. For the Chuck Norris one, so I have more IDs here, or more values here, right, that I have access to. So it really depends on how you see using the data. So I could
Mm-hmm.
normalize this somehow if I wanted to, or I could just create two different types. So like I could create a Kanye response.
Right.
So Kanye response, and it has an ID, which is a string, and I believe I called it quote. And then we could do that here. And then I could just return that data down in my resolver. So if I were to restart this now, I can fetch an ID and a quote from Kanye now. And we have to refresh this too. And now we get both of those. So you can pretty much grab as little or as much as you want from the response. The idea is you grab the data from the API, and then you can normalize it in some way that you like. You don't have to normalize it at all. Like right here, we just exactly matched the response ID quote, but you could just pick off the fields that you want if you wanted to, or you could let the user pick off the fields because it's GraphQL, and I could just say, I only care about getting the quote. I don't care about the ID. So you can just grab it like that. And then we're just getting the quote here. So you can kind of choose where you want to do your normalization.
And do you do the normalization afterwards? So again, an example might be where I didn't exactly catch the two APIs there, but you might have, for Kanye, you might have ID and you might have quote, and for Chuck Norris, you might have ID and quotation, and then you actually want to
Use the
merge
same
those two
type for
APIs
both.
and use the same type for both. How do you kind of just hit those individually, or what would be your process for handling that?
Okay, so
Does
we
that make
can go,
sense?
yeah, that definitely makes sense. We can go over example. I would say you could approach that in like two different ways. So here's way number one. Way number one is if you want them to have the exact same response, you can normalize them to the same type. So for example, I'm just going to call this a quote response. And all it's going to return is a quote in here, because I don't know if Chuck Norris had an
Right.
ID. Yep, Chuck Norris has an ID. So we could do an ID and a quote for that. So quote response and Chuck Norris. So they're both going to return quote responses. And so Chuck Norris doesn't have the same names, right? So he uses
Right.
value instead of quote.
Right.
So what I can do here is I can return it, and I can say the ID is data.id and the quote is data.value. And so this is, say, our normalization. So we fetch from the Chuck Norris API, and then we normalized it like that. And the other thing you could do is, yeah, I think that's the best way to do it, actually. I was going to say you could actually create a resolver for the quote response, but you don't know whether it came from Chuck Norris or like Kanye. I think the best way is to do it probably right here after we fetch
Right.
from the API and normalize it like that. Now, you could also tell me, I don't want to normalize it. I want two different types of responses. And then you could do like a union in that case. I don't remember the syntax for unions off the top of my head, but you could do something like go back to our Kanye response. He has these values. And then you have a Chuck Norris response. Let's call it Chuck response. And he has those two fields. And then we may want to capture more, like let's say the URL and the icon URL. So he has way more fields than he does, and he has different fields. So we could return a union from this. So we could either like make this a union. I want to say the syntax is something like union. I guess I could call this quote union response. And that's either a Kanye response or a Chuck Norris response. I don't think that syntax is right. Let's just see if this throws an error at us. If not, we can Google it real quick. Type is missing a resolve type resolver. Oh yes, so I think my syntax may be right, but I didn't add. So whenever, I don't know, have you dealt with unions before?
I have not.
So I guess we can either go down this rabbit hole, or we because there's a one other thing step we have to do for unions. Are you interested in the union rabbit hole before we go down that rabbit hole?
Well, I think it really depends upon what the benefit of it is. So the example that you were showing before, it's where okay, you hit the Kanye API, you hit
Hmm.
the Chuck Norris API, you kind of those go back to a single type, which was quotation, I think it was, and then the user could then go and just kind of hit that quotation query, and then it
Hmm.
would hit both the, and I think that makes perfect sense. What is the value of doing a union on top of that?
So I guess so. Our example here is kind of probably like right here is not where I would use a union. Let me put this
Right,
back. I think the quote response is probably the best thing for this. But you could have a field here called Kanye or Chuck quote, right?
right,
And then that returns a union. And so I think that makes a lot of sense. So
got it.
basically, the idea is if I get a Kanye response back, I want to grab these fields. If I get a Chuck Norris response back, I want to grab these fields. So you'll use them
Right,
in kind of two different ways.
right,
If you want to normalize and have one type of recipe, then you would do the first technique. If you wanted to say I want to have like three different types of recipes you may get back, you'd want to
right.
use a union.
And I think what I'm trying to do, and you can tell me which one makes sense, is I want to really kind of just hit multiple APIs and say I want show me recipes that use mozzarella cheese, and I can
Hmm.
then hit two different recipe site APIs and bring back whatever recipes they have for mozzarella cheese, and
Yeah.
then bring those back together into a single response where I would return the 10 from one site, the 20 from another site, and then you would get all of that back in your GraphQL query.
Okay,
Does
I
that
get
make
you.
sense?
Yeah, definitely. I think then maybe, so like you don't even have to do something like this. I think so for that case, what it sounds like is I would probably say normalization is probably the one I would go for,
Hmm.
mainly just because I don't think it. Let's say you're getting it from 10 different sites. I don't think it makes sense to have 10 different response types or something like that. I think you probably best just to normalize the 10 APIs into a single recipe that you generically use across. I think that makes the most sense. And so, like in the case that we wanted to do something like that, I think it looks something like this. So let's say we want to say like search recipes is what we're going to call it, and that takes like a query, and it's going to return back an array of recipes, right? So I'm guessing like is this kind of like the type signature that you're
Right,
looking for?
exactly.
Okay, so for something like that, I would even say I would just have a single resolver down here called search recipes. And we can close this. And so this would be like, we don't care about the parent, which is the first parameter. And the arguments is going to be query. And then I would just call the 5 different APIs or whatever. So I would say like, and again, if you want to make them all, it sounds like also I'm guessing that you want them all to run in parallel when you're hitting the different endpoints.
I think ideally that would be great. No reason to wait for one to finish to next load the next one.
Okay, so let's say these two are our two recipe endpoints. I would say instead of putting a wait there, I would say promise 1, promise 2, and then you could just do this for every single API you have. And if you need to, like, you can pass in as a parameter here the query, because the API probably takes a query or something.
Right.
I don't know, like keyword equal query. And then at the end, I would say you'd have basically an array of data, and you can await, say promise that all.
And you have an array of data because after you fetch each one of those, you would add it to that single data array.
Exactly. So now, yes. So this is
Right.
an array. So you could even destructure this if you wanted to, and you could say recipe site response 1, recipe site response 2, and so on, because you may need to normalize from this point, right? Because now you have like 5 different responses from 5 different recipe sites, and you want to normalize them into a single type of recipe.
but just like the example you used above, you might still need to do, again, like where the Chuck Norris side called it value and the Kanye side called it
Yep.
quote, you would still need to do, when I do that initial fetch for the first API and the second API, that would be the place where I would then map that before or after.
So
Oh, you're showing me
I would
after, right?
literally do this sequence right here. So I would fetch them all. So I would
Uh,
basically have like 5 different fetch queries or whatever there. And then I would wait for them all to respond and get back. And then I might have name, and this is called recipe name. Whereas from
right,
the second site,
right.
it's called just name, right? And so I would do that for every single one. So this one might call the servings yield, whereas this one calls it just servings.
Mhm.
And so I would actually, this is what the stuff would look like. I would do, and you may, again, this may be a for loop if you're getting back more than one recipe from the response, but
Right.
this would be the fetch your data, resolve, like get it back from all the APIs, and then normalize it.
Fantastic. That makes perfect sense.
Cool.
And in that case, from the destructuring standpoint, the recipe site response one is the results from P1, and the recipe site response two is the results from P2.
Exactly.
That's
Yeah, we could just rename this to like pdo data,
right.
whatever we want to. And then so like yeah, I don't think you even need to get into for this particular use case. Like in this case, I have an advice resolver where it's going like a level, like I'm resolving the advice type fields. I don't even think you need to resolve the recipe fields. I think you can put all your logic in the search recipes resolver.
Right. And so, and again, the last part is that in that return loop for each one, if I'm returning multiple recipes from each site, I would just have where I have the name P1 data, recipe name, and servings P1, that would be in a loop that would go through all of the data in P1 data,
Exactly.
correct?
So it may look something like this. So let's say we have, we can call it normalized P1 data is equal to P1 data.recipes.map. And then for each recipe, we are doing this, right? And we're doing x.recipe name. So now we're looping through the array of recipes that we get from the first site. And we're saying, let's get that recipe name, let's get that yield, and we're setting the values to name and servings. And now I have an array of those, all right? So I could just say dot dot. I don't know if you're familiar with the dot 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 syntax.
Yep.
So you could just do that. And so now you're just passing in all the recipes you normalize there into the normalized array. So depending on the site, if you're getting an array, you map through it. If you're just getting a single recipe back from the site, you could just do a response like that.
So, okay, let me just make sure I have this for here. So,
Yep.
so you went and you said normalize P1 data. It's going into P1 data, mapping it, and that's returning the name of the servings. Then, how is that then being merged with the name and the servings second site?
For the
Is
second
that
site?
so? You have normalized P1 data there. Is that being returned and integrated with the name of the servings for P2 data, or would you just do the same thing for each one and then have that
So yeah,
be returned as
this is
well?
going to integrate together. And let's say P2 data is an array too. We could say
Right.
normalize P2 data. And we could put the logic we have down here, move it up here, use P2 data, and then we could spread it in there too. So let's say let's
Got
assume
it.
you're only getting arrays back. For each array of data you're getting, you're just merging them all together at the end like that. Oh, and this should be X. Because, yep, after we're
Right.
mapping through the recipes, each one's that.
Okay. Well, that makes perfect sense. Thank you.
Yeah. Is there anything else you wanted to go over? You have any other questions?
Well, I think one extension of this, since we do have a little time, is, and you kind of brought this up previously, is caching of this, the data that's being returned.
Yes.
Um, and do you have any videos that kind of touch upon caching or in this regard about so you wouldn't have to keep making the same hits to the API?
So what I would suggest in this case is I think I have like one video that may be relevant to you that has to do with Redis caching, but we can basically cover that real quick
Okay.
with I'll give you like two different ways you can do it real quick. So there's this thing I mentioned to you called data loader, but I don't think data loader will be relevant for what you're doing right now. Because right now, really what you want to do, and correct me if I'm wrong, let's say someone searches pizza, or I guess mozzarella. So someone searches mozzarella. Uh, you want to cache that so the next person that searches mozzarella, you already return the response to them and you're not hitting the API 5 times. Is that the idea?
So I think you're right about the data loader that might come into play on some level, but I think that is the question. Is that something worth doing? And is that something that can be done effectively?
I definitely think it's worth doing, and it definitely I like you can start very simple. So the simplest thing I would suggest to you is I would create an object called cache like this, and this is how I would recommend starting. And then so this object is basically going to store previous data. So let's say we have our query. This is mozzarella. We hit the API, we normalize the data, and this is like what we're gonna totally normalized. So this is what we're going to return, right? Totally normalized. So this is what we'd normally return to the user, whoever searches for mozzarella. We're just going to say cache is equal to the query is equal to totally normalized. So basically all we're doing is we're storing the data that we would return inside of our cache, and the key is the query the user searched. So then we can just add at the very top here, if cache contains the query, return it. And now this cache object, it's just an object sitting on our server. So it's not gonna I don't know how big of how many requests you expect to get hit, but that's where something like you could replace this with say Redis, and you'd be able to handle some more data instead of just having it in memory. But this will definitely hold you over at least to start and gives you a good idea of how it will work. And you can just say check the Redis cache, see if it exists. If it does, return the data in the cache. And then here we're filling the cache. Here we're checking the cache. And here cache hit. And we're returning data from the cache. So the idea is once someone searches mozzarella, it goes through here. We're going to fill the cache with mozzarella. Next time someone searches mozzarella, it's going to be in the cache. We just return it, and the fetches never happen.
Great. And typically, then, do you have the cache? Can that expire after a certain period of time? Because I'd imagine at a certain point you want to go back to make sure that there are any new recipes for mozzarella.
Yep, that's another good thing to do. So with Redis, there's a way to say for example, I only want this to be like after you store it. So fill the cache, and it'll say expire after X seconds. So you can choose how long it expires. So if you want it to expire in a minute or in an hour, you could pick whatever time you want. With an object, I don't know the simplest way to do it. Maybe you just say you keep another object called cache key, or for example, I want to store the date that the key was stored. So maybe we have date stored, and you say date stored is equal to new date. So basically we're just storing the date that the query was first filled in the cache, and then when we go to hit the cache, we can say and oops, and we can basically here just check the date, and we can be if the date is no longer than 1 hour, you're good to go. So I guess that check would be something like that. But for the long run, I would suggest something like Redis or Memcache would be your best. But if you wanted to start with something simple like that, you could. The date stored thing feels a little weird. I don't know if that's the best way to do that particular thing, but something to that effect.
Okay. Well,
But
thank you very much, Ben, and thank you for all the videos. They're all very helpful, and this definitely takes it to another level.
no problem.
And I
Is there anything
look
else I
forward.
can answer for you, or?
Nope. I look forward to the next time we talk.
All right, see you then.
Okay. Thanks a lot.
Bye.